Hello students, our today's topic is graphical representation of motion. So today we will see that how we will represent the motion in the graphical manner. So to describe the motion in graphical manner, we have three types of graphs. First graph is position time graph, that is we can say xt graph, that is position time graph. Second graph is velocity time graph, that is VT graph, velocity time graph. And third graph is acceleration time graph, acceleration time graph. So these are three types of graphs which we use to represent the motion. But here today we will discuss these two types of graph, xt graphs and velocity time graphs. Now we know before discussing the graphs, let us discuss some important terms and some different situations under which we will draw the graphs. First of all, let us see, we will see acceleration is rate of change of velocity. So its formula is dv upon dt, or we can say for large changes delta v upon delta t. This delta represents the change in velocity and change in time. So how can we describe the change in velocity? Is final velocity minus initial velocity. If v2 is final velocity and v1 is initial velocity, then change will come when we will subtract the initial velocity from final velocity. Similarly, we can write the time t2 minus t1. Now when will the acceleration will be positive? Acceleration will be positive when v2 will be greater than v1. And when will the acceleration be negative? Acceleration will be negative when v2 will be smaller than v1. This type of acceleration which is negative, we call it retardation or deceleration. Now how we draw the graphs? For drawing the graphs, we always choose two axes. One is x-axis and one y-axis, and one is x-axis. So this vertical line represents the y-axis and this horizontal line represents the x-axis. So for example, we are drawing the position time graph, then position, that is x, will come to the y-axis and the time will come to the x-axis. Generally on the vertical line, that is on the y-axis, we take dependent quantities. Dependent quantities are that quantities whose values vary according to the second quantity. So these are dependent on these quantities that we take on the x-axis. Similarly, we can draw the velocity time graph. Velocity time graph, we will take velocity on the y-axis and time on the x-axis. Now we will discuss about the different situations which we will use for drawing the graphs. So that different situations are that when body will be at rest, body will be at rest when x is equal to, x is constant. When x is not changing, that is position is not changing, then we will say that body is at rest, that body is not moving. So x will be constant in position time graph, then body will be at rest. When will be body in uniform motion? Uniform motion will be described when equal distances are covered in equal interval of time. As we discussed it in earlier videos, uniform motion is said to be when any body covers equal distance in equal intervals of time. At that in this situation acceleration will be 0, because there is no change in velocity is constant, so here acceleration will be 0. And next situation is non-uniform motion. Non-uniform motion. In non-uniform motion, velocity is not constant, because velocity will be varying with time. So there will be some acceleration, because as we know that acceleration is rate of change of velocity. So here acceleration will also not equal to 0. So these which we have discussed the important situations for drawing the graph, that is rest, non-uniform motion, uniform motion, and retardation, deceleration. Now come to the first type of graph, that is position time graph. So let us draw the position time graph. Position time graph, firstly we take the graph of rest when body will be at rest. Firstly, how we will draw the graph, we have discussed it earlier, that position will be on y-axis, time will be on x-axis. So this is the graph of rest when body will be in rest. Here we have discussed that position will not change, that x will be constant. So when time will be changing but position will not be changing. For example, if time comes to this point, then body is at this point. As time increases but body is not moving, body is at the same point. Time is increasing but body is stationary at the same point. So here body is not moving, body is not changing its position in anywhere like here. So body is at the same position. So here x is the constant. So this is the graph of rest. Next, second graph is of uniform motion. We have already discussed it, uniform motion, that body will cover equal intervals of time, equal distance in equal intervals of time. For example, x, t. This graph will be drawn like this. Here position will be changed but with same amount. For example, for first hour, position body covers the distance 1 kilometer. For second hour, body covers the distance 2 kilometer. 1 kilometer means total 2 kilometer. For third hour, it again covers the 1 kilometer, that is total 3 kilometer. So for equal interval of time, equal distance is covered by the body. So this type of graph represents the uniform motion. Whenever we will see this type of graph, we can say that this graph represents the uniform motion. Next, when we come to the non-uniform motion, for non-uniform motion, the graphs will be like, which we can draw x, t, x, t. We can represent it like this, it can be represented like this, and it can be represented like this. So here position is not constant, position is changing with the time but not uniformly. Here position is changing non-uniformly. This is not compulsory here that in equal intervals position will be changed by distance will be covered by equal pace or equal interval. So these type of graphs represents the non-uniform motion. Whenever we will see such type of graphs, we can say that these represents a non-uniform motion, that is xt graphs. We know that curves of xt graphs represents the velocity. So curves which are drawn in these graphs represents the velocity, because velocity is rate of change of position. So here we are showing that how position is changing with the time. So these curves represents the velocity. Now when we come to the velocity time graphs, our second type of graphs are velocity time graphs, which we are going to discuss. In velocity time graphs, we will discuss the same situations which we have discussed in the position time graphs. So here, when the velocity time graph is straight line having positive slope, means for uniform motion, what will be the velocity time graph? Here we will draw the velocity time graph same. Our velocity will be represented by y-axis and our time will be represented by x-axis. So here for uniform motion, when uniform motion will be there, the slopes will be like, firstly we are discussing the uniform motion. Here if there is a straight positive slope, it means that velocity of the body increases at uniform rate. So this graph represents the uniformly accelerated motion. We know curve of the velocity time graph represents the acceleration, as we know from the definition of acceleration that acceleration is rate of change of velocity. Here how velocity is changing with time, this graph, this curve is telling us. So this curve represents the acceleration. So for uniformly accelerated motion, we have drawn the graph. Here velocity is changing with the time but uniformly. Uniformly means in equal intervals of time, velocity is changing with equal amount. So this is the and this is positive slope, means increasing. So this is the graph of acceleration. But if we see the graph of retardation, what will be the graph of retardation? If we have the curve negative slope like this, here firstly velocity was more, but as the time passes velocity is decreasing, but decreasing uniformly with equal amount. So here this curve shows the retardation. This curve shows the retardation. Retardation means negative acceleration, means velocity is changing but velocity is decreasing. So here these are the two graphs for uniform motion, that is for uniformly accelerated motion and for retardation. When velocity will not be changing, like zero acceleration, here we have the graph for zero acceleration. Zero acceleration means here this time, this velocity. Zero acceleration means velocity is not changing, that is as time passes velocity is same, time passes velocity is same, time passes velocity is same. So here this is the graph for zero acceleration. Now come to the non-uniform motion. One important thing which we can here discuss, that the area under the curve of this graph gives us the displacement of the body. So for example, we have this graph or this graph here. The area under the curve always gives us the displacement of the body. For example, I can give name PQR. So area of triangle PQR will be equal to displacement of the body. So for numerical problems, we can learn this formula. If we have to find the displacement of the body from the graph, then firstly we have to calculate the area under the curve, like area of this triangle PQR. Then we can find the displacement. Now come to the non-uniform motion. Non-uniform motion, these graphs will be like this. Here we can draw the graphs. Y-axis, x-axis. Y-axis represent velocity, as we are already discussed. Dependent quantities we take on y-axis and independent quantities we take on x-axis. Dependent quantities means which depend on the another quantity, whose variation depends on the another quantity, because velocity is dependent on time. With the time this is varying, but time is independent. Time doesn't depend on velocity. So here such type of graphs will be formed. We can represent like this, we can represent like this. So this is the positive slope, that is acceleration is increasing. Positive slope, acceleration is increasing. So here negative slope means acceleration, velocity is decreasing. So these here velocity is changing but not uniformly. With unequal amounts velocity is changing with time. So if we see such type of graphs for then we can say that these are the velocity time graphs for non-uniform motion, where velocity is changing but not uniformly. If velocity is increasing, then it will be positive slope, that is acceleration. But if velocity is decreasing in such a way, that will be negative slope, and that will be deceleration, or we can say the retardation. So these are the graphs which we have today discussed: apposition time graphs and velocity time graphs. Thank you so much.